And we are on. Good morning, good evening, good afternoon to everybody, depending on where you're attending from. This is Kubernetes API Machinery bi-weekly meeting. Today is January 26th of 2022, the first meeting of 2022. 2021 flew by very quickly. Let's see how this year behaves. And we have a nice agenda for today. So with any further delay, let's get started on that one. The first topic, I think, is from, I don't know your name. I see only your.
Hi, I'm Konrad. It's just like my LDAP.
Okay, very good. Do you want to take it over? I can open the document if you want.
Sure. So there is this long-standing issue, the moratorium for removing old storage versions. It was established in 2017. And the problem is we cannot really get rid of old versions of old API versions because we cannot guarantee that there are no more instances of these versions persisted in database. There was one attempt to solve this problem happening over early year 2021. But it was stalled for unrelated reasons. The proposal that I prepared achieves the same goal, but does that without introducing new API objects and without introducing new components. So I think it is a simpler approach that lets us accomplish the same thing. And Daniel already did a few rounds of review. Thanks for that. It looks like the most potentially contentious part of the solution is that it is not identical for CRDs and for built-in types. And I believe it should not be the same for built-in types and for CRDs. I would love for it to be the same once the built-in types have been migrated. And also, I consider the CRD problem to be much simpler because we can prevent removing old, because API server is the entity that has control. Has the veto power over removing old API versions. So it can prevent doing that when there are any potentially disrupted entries in storage. So I would love for it to be the end of the story, but for the API server, it is not. There are built-in types, and the API server cannot say, please don't update me until I'm done with this. So the next best thing the API server can do is to try to do as good a job as possible. So potentially cooperating with external controllers. But otherwise, for cases when people are not aware, or when users are not aware of that, it should be very, very, very likely to do the right thing out of the box. And that is what this solution attempts to achieve.
David, do you want to, or I have things to say, but maybe I should go let other people talk first. Specifically, I imagine David has some things to say.
Over the details if needed. Oh, barely. It's very quiet.
Oh, okay. So I am talking. I'm just too quiet.
Oh, yeah. Oh, yeah, David, you're super quiet.
All right. Very, very low.
Better. Oh, there you go.
Yes. Okay.
Better.
So I am in favor of finding a way to bring migration into something normal, in a normal flow.
so that we can get rid of old unserved versions. I think that would be good for us. I have not read this design. It sounds like it is not a full replacement for the storage version migrator, because the storage version migrator can also be used to trigger a read-write cycle to do things like rotating KMS keys. So this is focused on a more narrow problem. Did I understand that correctly? Just want to make sure so we don't position it as a replacement.
I'm not familiar with the idea of replacing KMS keys, so it's hard to me to really say whether it addresses this problem.
So briefly, if you enable encryption on, I mean, you can do it on any collection. There's a data encryption key which is written with the object, and occasionally people want to rotate that, which involves reading the object, generating a new data encryption key, and rewriting the object. API server does the right thing if you just read and write the object when the key has been rotated but not forgotten yet. But you still need a way to trigger this going through the whole collection.
Yeah,
if that makes sense.
I'm not saying this must cover it. I want to make sure that I've correctly understood and that we know this is not a replacement for the storage version migrator.
It does not run a read-write loop for objects that are not about to that objects that do not carry versions that we would like to remove. So
well,
yes,
I mean, it's also the rewrite behavior isn't triggerable by users, right? It happens on API server startup.
Okay. And then I am somewhat concerned, not concerned enough to stop it probably, but somewhat concerned about the behavior on like full lists of large numbers of objects or large objects. There's also a KEP being proposed this release to address memory usage for our informers. And while I don't think it would block an alpha implementation, I do think we would want to see these characteristics before we allowed this design to go to beta.
So the resources load information that makes me not worry about the resources too much is the fact that we already populate watch caches on API server startup. So for the full lists, that would be no, for the reading alone, there would be no additional load. There would be an additional load for writing, but that is constrained somewhat by one of the aspects of the design. Basically, we want to allow one release before actually triggering an active migration of the resources. So we allow them to stay in these supported but not preferred versions, so that when the API server updates them in regular traffic, they will just migrate organically. So that would lower the amount of writes.
I may have stale info here, but I seem to recall that the watch cache is configurable on or off, and not every collection is on by default, and not every installation runs the watch cache. Unless that's changed when I've been out.
So I think it's definitely not installation have to run it. The default is that it's on for everything except from events, and events given TTL are not a problem because like they have TTL, right? I think the concern here is that people or particular installations can switch it off. Yes.
All right.
I'll want to read in detail to be, I guess, just as convinced as you are. I would just bring it up because it'll be one of the things that I'm reading for in beta criteria.
So I guess my thoughts on this are, I don't understand why we would do this rather than finishing the storage version migrator and, for example, moving it over to controller manager. If the concern is that it's not run in in many installations, which is probably true. Yeah, so I don't. So if we were starting from scratch, I agree that this is probably a more direct route to solving this narrow problem. But the storage version migrator is written and mostly finished. And so starting from where we are now, I'm not sure that it makes sense to throw that away and start from and like redo this. Also, I feel like the storage version migrator has some features that you will eventually that are not mentioned in the design that you'll need to add, like restarting from the last known position rather than the beginning. Wojciech mentioned this in a comment, but is not mentioned in the document, at least when I read it. So
that's actually
the
a good
last
point.
one, you mean for the update loop? The reads would happen always, like we would always read everything. It's just the writes would restart from the last known position just by the virtue of them carrying this version that needs update or not.
Right, the storage migrator remembers where it was, so it doesn't even have to do the reads. That gives it a much stronger guarantee that it can make progress.
I would be okay with moving the storage version migrator to the Kube controller manager. It does appear to do what we expect it to. We run it in OpenShift for KMS integrations.
Yeah, I think from my perspective, I think I don't fully agree with the concern about like not the like that starting, like it requires visible non-negligible work to not start from the beginning. I think like from my perspective, the biggest concerns are the difference with the CRDs and like what David mentioned, which I didn't follow. Like
I agree with that. Like the difference between CRDs is the biggest thing in my mind. I only mentioned the restart behavior as an example of something we figured out in the storage version migrator that you're going to have to figure out again doing it this way. I think it's not the only thing like that, but it's the thing that comes most readily to mind.
As I recall, we even added a special behavior in pagination to make sure it worked.
That's correct.
Yeah.
So the benefits of the loop on startup is that it is a bluntly a dumber approach. So by that virtue, it should be less error prone. There's less state to coordinate between the runs and so on. So just like
I would agree with that argument if the storage version migrator didn't already exist and wasn't already functioning. Like, given that it already exists and we think it works correctly, we're not comparing the two projects at their beginnings before they've been written. We're comparing like a working thing with a design that might be simpler, right? So I think that, yeah.
When you say storage version migrator exists and works, do you mean the version that relies on storage version hash, which only works for zonal clusters, or do you mean the version that relies on self-coordination, which is not submitted?
The storage version migrator, as I recall it, has an API that says, I request that this resource get migrated. And then it keeps the state about its current migration state for that resource written out.
Maybe I'm confused. My state of knowledge is that there's a bunch of pull requests that are mid-review and they were not merged.
I haven't refreshed my memory on the storage version migrator in a while, but
are we talking about the same project? I linked it in here.
There's a link to some pull requests. If you search for PR in this doc, it should be mentioned there.
I can comment on the state. So storage version migrator was going to use the storage version API, which is a site coordination for regional HA clusters. Currently, I think storage version API support built-in APIs, but not CRD yet. So the goal is to let the storage version API to support CRD and then move storage version migrator to use that for HA's clusters.
As an extension about how the read-write cycle requests could actually be created, right? So it's not talking about changing the API we use to say, migrate this. This is about how would I choose to start the migration.
Yes.
I see. Pull requests are mentioned in the SVM implementation. There is a paragraph on that. Oh, there. So the self-coordination API already exists. The pull request 85 actually changes the storage version migrator to make use of that rather than the storage hash, storage version hash. So it actually enables using that API from storage version migrator. And yeah, so I guess unless it's been shown in internal tests, then that I'm not familiar with. That's what I meant by storage version not actually doing this yet.
So I'm slowly remembering what state this was left in. One option that we should consider is keep the storage version migrator for executing the loop and have API server request a rewrite cycle when it notices that things have changed. Like use your detection logic that you've written here to trigger the loop in the storage version migrator. Because there are two parts of the problem, right? Well, there's the like actually go rewrite everything problem, which that the storage version migrator is already fine at, and that works and doesn't put undue load on API server, etc. And there's the like detect when it is necessary to perform this behavior, and that one, yeah, I guess I don't know. I don't recall the state where we left it. It sounds like maybe that one's not finished yet.
If we unload the loop to an external, say, webhook/controller, the actual writes still need to happen via API server. So from that point of view, it's equivalent. The part of logic that is like additional, like API server still needs to perform the reads and still needs to perform the writes and pass them down to the API clients, right?
Yeah, it goes through the regular handler chain. That doesn't change. The part that does change is the storage version migrator has already been rate limited and tuned and restarted to the right spot, right? So there's no mechanical problems with that, if that makes sense.
I'm not sure I fully follow, but I think this is something that we could follow offline.
Can I also ask some questions? This is Chao here.
Go for it, Chao.
Yeah, I haven't read this doc in detail, but how do you to detect that we are okay to migrate to the new version in the case of HA API server?
So if you scroll up to the table, that I know who owns the view, but basically every version for every built-in resource will get annotated with what I'm calling the storage behavior. So the first two are the ones that we are already familiar with. Supported means we can read and convert it into the internal representation. Preferred /storage is the one that will be used when writing. Now there are two new storage behaviors. One is actively migrated, and the version that is annotated with being actively migrated is the one that will actually get written by the API server on startup in a loop. The thing is, the policy for migrating through these versions, which is described further down in the doc, it requests that when the resource is no longer the preferred /storage version, it is it should be here, deprecation policy. It will be in one release as simply supported, followed by 3 releases as actively migrated. So there will be one release when the resource would be basically, there would be no, it would not be picked up by the rewrite loop.
Okay.
So we would just rely on the natural kind of, if there is a controller actively working on that, it will update by itself. And there's no changes in load, like everything is the same, apart from reading and finding out that we should do nothing. And only then we enter this actively migration, and we are putting 3 releases there just to capture the case when somebody rushes through updates multiple times. So answering the HA cluster question, when performing a rolling update for an HA cluster, the update can only happen by one version at a time, one minor version at a time. So the only changes that could happen here is going from preferred /storage to supported, so the loop will not be invoked, or going from supported to actively migrated. So ideally, by that time, for the resources that are managed by active controllers, all of these resources would have been already migrated. For the resources that are not managed by active controllers, that they would just happen to like update the resource, which is like it needs to happen at some point. Does that answer the question?
I'm still not clear. So when we do the rolling upgrade of the HA API servers, it's only safe to migrate the resources after all 3 API servers have been upgraded to the new storage version, right?
No.
No.
When you introduce a new version, you need to have at least one release when a version is recognized but not used as preferred storage. That's per the deprecation policy.
No. That's not my question. My question is, when you do rolling upgrade, suppose one API server is in the new version, but the other 2 API servers are still in the old version. This is not the right moment to start migration, right? Because those old API servers, they will still write objects in the old version.
Yeah, so there is some potential for fighting between the API servers during the rolling update. But again, like if there is a lot of writes, say if there is an active controller working on those, there would be no more instances of objects needing upgrade, because like all of these instances, like all of these objects were already updated when the new version was indicated as the preferred storage. The version that's just retired from preferred, nothing is being done to it by the active loop, so nobody will fight with anybody there. The next step is when we actually enable this active actively migrated loop. And by that time, most of these resources should have already been migrated.
Who started this active migrating loop?
Sorry?
You said active migration loop, right? Who started?
The code that performs the migration runs on API server startup. The decision to turn a version into actively migrated, it will be handled in code. It would be like annotation or some sort of like every version would need to be annotated with that. And per policy, the progression, you are not allowed to go directly from preferred storage to actively migrated, exactly to avoid this kind of situations.
Okay. Yeah, I think I need to read the stuff. I'm still.
This exact.
So if I can sum it up, like the general synchronization mechanism here is all the API servers race, but hopefully the rules have been arranged such that the race arrives at a good conclusion and they don't fight too much along the way, which I mean, we've done it in some other cases, but I can't say it can work, and it can also not work if we mess up the right, like if ever the rules are not followed in some release, or it just seems like there's a lot of ways that it could go wrong, and we could end up with API servers fighting. Yes, they shouldn't, but I mean, right? So that's how I generally feel about this kind of synchronization mechanism. Yeah.
There is a potential for the policy not to be followed, and yes, it is more complex than the previous. You can never remove a version. So I imagine there could be, we could build some automated checks to help us ensure that. I'm not sure.
I think basically, I think you're working around the fact that the cluster has no idea what version it's supposed to be on. Right? If the cluster knew what version it was supposed to be on, then it would be relatively easy to watch for transitions in that and then do the appropriate thing. But the cluster doesn't know what version is supposed to be on. So that's I think at least one of the things in the API that we haven't completed yet for the storage version migrator is like you can figure out what version the cluster thinks it's supposed to be on by seeing what the API servers think they're doing, right? And I think that is going to be useful to a lot of other things, not just this thing. So I think it is worth it. I know we already went over this in the comments here, and you're like, well, nobody's needed that in the 2 years since we talked about it. But I think people would be using it if it existed, but it's a lot of work, so nobody has the bandwidth to both build it and use it, which means that a lot of people work around it in cases like this. So I'm not sure.
Yeah, my view here is superficial. I don't have like wide knowledge of like all the cases that could potentially be migrated to the like self-coordination approach and result in a cleaner code overall. So yes, it is possible. You know, I cannot really speak to that. Like you said, all that I observed is that there was a little push.
Yeah, I should also say that I don't care personally about getting stuff out of the code. I mean, yes, that would be nice. The thing that I really care about is not having weird things in the database, right? Like even if a storage version is in the code, but it's like 15 versions old, and like, you know, you never know what's going to be that change that is going to start triggering bugs in those really old clusters. So I want the storage version migrator not so I can necessarily just delete code, but because it unifies the contents of the etcd databases, which is going to reduce the risk of strange things happening at runtime, right?
And those strange
So-
things happen because we have defaulting code, for instance, that never gets executed except for that. So like, it seems like you want both. You're saying like, if the code was never used, you'd be happy having it sit there. I mean, I guess.
I mean, yeah. No, it's great to remove the code, and that is right. That's great. But yeah, even if the code is in there or we can't remove it yet, just confining the number of possible storage versions to 2 seems pretty useful to me, even if it takes a few more releases before we can remove that third old storage version.
Yeah, I mean, there is even benefit to doing a read-write cycle where you didn't change the serialization format, but the defaulting rules changed, for instance, because then those get persisted. And so if the code breaks, I'm worried about the code breaking, where like somehow you do a read cycle and it doesn't do what it's supposed to do because your thing hasn't been written in 2 years. I'm worried about that case, and that's why I want to remove the code so we know it isn't buggy.
So, but there's weird things that can happen operationally also, like imagine the etcd database gets corrupted and you read that object like 2 years later and all of a sudden you can't read it anymore. If you go through the objects more frequently than every API server reboot, that might be good. Of course, if you manage to run your API server for 2 years, that's pretty impressive.
If I can may answer to the etcd corruption comment. So this also stems from the fact that API server is like doesn't know which version it's supposed to be at. So like which is I consider equivalent to the way I'm thinking about, which is about control. Like API server cannot say like, please don't update me, I'm not ready yet. And this limits this solution just as it limits the SVM. If we allow for arbitrary version like updates by like many jumps, many minor versions on the same storage, like there would be by definition no solution that allows us to avoid database corruption while removing old code. So this is a problem that both SVM and this solution suffer from the same reason, that API server cannot control its own upgrades.
So that maybe reminded me of something else that I've forgotten to say, which is this code can only go forward, right? So if we were to merge this, like you could definitely never roll your cluster back 2 versions. Storage version migrator works both ways. So if in some extreme case you wanted to go back more than 2 versions, as long as you did it 1 version at a time, the storage version migrator could maybe save your data. I think that's an exceptional case, and we don't have it in as a supported thing that you should be doing, but it maybe is worth mentioning.
Yeah, I relied on the policy which says that we only support rollback by 1 release.
Yep.
But yes, like this exceptional case would not be supported.
We've been on this one for 35 minutes, and we've got one other thing on our agenda, so maybe we should go to the next item. I don't know.
And there's the pull request for the actual version of this in a KEP format. So I'll be able to continue the discussion there.
Yeah, that sounds good.
Okay.
Can you hear me, guys?
Yes,
Yep.
we can.
Okay. All right. So I just want to let you know that this KEP is ready for review. I would like to ask you to take a look and provide feedback. I won't go into much details today. I did that during a SIG scalability meeting last month. You will find a link to a video and slides in the agenda. So please take a look. So just in short, this document proposes to change the way informers get data from the API server. So instead of issuing a list and then watch request, it proposes to open a single watch request and stream data back to informer. And the reason we would like to do that is because we would like to decrease memory consumption of an API server. So it turns out that list calls might be expensive, even if served directly from the Wakash. You will also find a manual test we did described in the document that shows just starting a few informers might be enough for an API server to use all available memory on a node and simply cause a disruption. So we've provided a PR. We ran the test against that PR just to validate the idea. And the results seems promising. So we saw significant improvement. So we were able to run more than 1,000 informers versus just 16. It seems we can do even better than that. So there's still room for improvement. So we hope we can, scale this even further. So if you are interested, please take a look. Let me know what you think, unless you already have any questions about that.
Yeah, I haven't. Okay, go ahead, David.
I have a specific question. If you got a general one, Daniel, I'll let you go first.
I've got both kinds, so why don't you go first?
Okay. So Lukasz, when I was reading through the PR, there was some significant detail about implementation, and Wojtek had questions about how you were going to handle cases around slow watchers. And when I read the comments and the responses, it looked like that was still outstanding, and I wasn't sure whether you'd managed to find a solution yet. I see that as a blocker to an alpha. So how is that progressing?
So that is correct. So this is something I still need to sort out with Wojtek. I think I might have proposed a solution, but I haven't seen him replying on that. But
okay,
if you could scroll down,
I see
but
that as
I think
required
it's
for
doable.
alpha. I don't think we can ship an alpha that doesn't handle this, and so I think that would prevent me from approving the PR. Because if I'm understanding correctly, what it would mean is we could end up in a case where we either get stuck on these slow receivers, or we end up in a state where we're not able to make progress.
Yeah, that is also the biggest blocker in my opinion. I mean, I added a bunch of comments, but like this seems to be the biggest one. I'm not sure it's a blocker, implementation blocker for alpha, but I'm not a decision maker here. For me, it doesn't seem like implementation blocker, but like sorting this out is a blocker. Yes, I agree.
Oh, stop. I think, yeah. So that's the issue, right? So I proposed something, so we need to, sort it out. If you like it or not, you can do that offline.
Okay.
But it seems we can find a solution to that problem.
Okay, the first thing I thought when I read this is that it seems to be a bug in API server, like almost a security bug, in that a request, even a fairly normal request, can make it run out of memory. But the proposed solution consists of client-side changes. So that doesn't seem right. If there's a bug in API server list, it needs to be fixed there, in my opinion. And I suggested one such fix, which is API server can just arbitrarily reduce the page size. And that seems a lot simpler to me. So I don't know. Did you have a chance to see my comment?
Yeah, so initially we actually thought about that, but the challenge is we would have to predict the size of the object, right? And then based on that, we'd have to predict the page size. I mean, the safe page size an API could handle, right? And in some scenarios, like the test we did, right, that would mean we would have to heavily throttle API server, because a few list requests to the API server can consume gigabytes of memory, and this is extremely fast. So we are talking about, yeah.
Sorry, but if API server decides a page is only going to be 2 items,
yeah, we could do that. We could do that, but then you would have to issue many requests to the server to consume the whole list, and every single
right? But what's the problem? What's the problem with that?
request, it just seems it wouldn't scale. I mean, streaming.
Why not?
On the other hand, I mean, you would have to issue many requests, right? And each would consume memory, each would consume CPU.
But I don't
Yeah.
get it. What's the difference between streaming these as at a watch versus streaming them one at a time in separate requests? I mean, were you potentially using HTTP2 and there's no actual connections being dropped and remade. So,
but there is a per request overhead, right? Like the processing the request, like you need to get the response to send another one, and so I think.
Yeah, but if you're talking about gigabytes of memory, then clearly the per request overhead is negligible compared to the body of the request.
It's true. I'm not saying about the size of like the additional size of data. Or the memory aspect. I'm talking about latency. If we would need to send like 10,000 requests or whatever we decide, then like the latency of processing of sending and getting response for all of them, because they will be serialized, will be huge, right? So I think the way I think, I didn't yet have a chance to respond that, I didn't see that comment, but the way I'm thinking about that, I actually like the streaming approach. Solve this the solution for solve like, or the solution for the APIs problem, how I see that is that once most of our stuff will be using streaming, then we can actually configure PNF to heavily throttle all the list requests, and like those unpaginated, we will allow only 1 or whatever, like 2 or whatever in flight, and that will address the problem that API server can blow up in memory.
I think I'd like to see some experiment that demonstrated that the latency is going to be too high if you do this in requests of like 10 items instead of 500 items or something like that.
I think that shouldn't be a problem, but I think we were doing those experiments. I think like when in our scalability test, when we were trying to list 100,000 pods in the items of even 500, we couldn't keep up within the window. Like we couldn't do that within the like history window of etcd, so like 2 minutes or something like that.
Yeah, I actually, so another thing I linked in the comments is an issue I wrote up a while ago, which explains when it takes more than 60 seconds, how a lister can still catch up with the entire state and know that it's got the state.
I agree, but I think that like the solution is again like client side kind of. And I think like this streaming one is actually that Lukasz is proposing. I think it's like conceptually much simpler and much less error prone, in my opinion, at least.
Yeah, so I can't speak to the proposed solution because I haven't read it. I haven't read the detail yet. Yeah, I don't necessarily disagree with like, I don't know, what are you going to do? Use a bookmark to tell the client that it's now up to date and it can start reading. Yeah,
exactly, that's the idea.
I don't necessarily disagree with that. I just don't think it fixes the issue that the KEP has established as a problem.
It will alleviate it for well-behaved clients, which I will agree is not, I think I even commented on this, is not the only set out there, but it is one that we can make work in a way that improves KEP API server behavior.
So my point with the page size reduction is that I believe the server can unilaterally just do that. and existing clients will continue to work correctly. So I don't object.
Yeah.
I definitely don't object to making the watch. It's safe to use the watch catch-up function. So right now I don't consider that to be safe at all. So I don't object at all to fixing that. But I don't think it fixes the problem that the KEP describes.
So you're referring to the long-standing issue about the watch cache being stale, right?
No,
No?
I'm saying right. So right now, if you issue a watch request in a certain way, it first lists the collection and sends you all the items in the collection. But there's no way for a client to know when it's reached the end of the list and started receiving watch events, and that makes it very difficult for a client to act on that. So it sounds like you would fix that. Like your proposed mechanism of solving this is to fix that problem, which I am in favor of. I just don't think it actually fixes this problem in the KEP.
I mean, probably there's more than one way, right, of making sure memory consumption of an API server is low. Some might be easier, faster than the others. The question is, which one do we prefer? Certainly, throttling everything just to grab one item probably would work, and
because an issue overhead. Yeah, an issue with fixing it that way and that being the only fix is that people have to update their clients to take advantage of it.
Yeah, that is correct.
So, I mean, there might be room for both. Like, hey, if you want to come up to date quickly, do it this way. If you keep on your paginated one, API server, for example, it may even have, I know we have stats on the number of objects in the collection. I don't know if we have stats on the size of a collection. If we had that, it would be easy for API server to compute a page size that's probably going to be okay in advance of doing anything.
One thing that came to my mind is that we would have to probably add pagination to the watch cache, right? Because as of today, by default, informers go or ask,
yes, that's right.
At least initially, ask. Get data from the watch cache directly. So we would have to change that to support pagination. That would be probably first step.
Why is it so bad if the objects are already in the watch cache and we're just serializing them all? Why is that so bad? I don't understand.
So the test I did, if you look in the doc, so the test I did was against the watch cache. I can give you a pre-prof. I mean, basically it's a decoding phase. Yeah, I think.
Why is there decoding if the object's already in the watch cache? Those objects are already.
No. So there's the distinction. So we only cache serialization in certain scenarios. So I believe we only cache objects that are in the sliding window store. So there are two stores right inside watch cache. One is that stores like all objects, and then we have a separate store.
It's even less than that. We are only like caching the serialized versions only for the current event, let's say, like when we are sending them to active watches, we are not caching any other serializations. And the problem, I guess, is that like when you have like 10 or 100 like in-flight list requests listing all the same objects, they will all be serializing their stuff like independently. And given that we need to store everything in memory before, like given that we don't do any streaming and like we are first preparing the result and only then like sending it to the request, then to the client, then having like a lot of in-flight requests means that like we will have a lot of copies of the same data in memory.
Sure, I get that, but what's the maximum response size for a list? Like even if you've got 16 copies of that in memory at once, that doesn't seem like it should add up to 16 gigabytes or whatever, or six
I think
gigabytes.
the response size for like this experiment was like gigabyte-ish.
You can get a list with a gigabyte response.
Yeah.
How many items is this list trying to get at once? Is it the entire collection?
The entire collection, yeah. But
Oh,
I think I added 400, I think, secrets. I don't recall it at the moment.
So
yeah,
I
something like
think we should actually serialize to no more than one at a time requests for lists that want the entire collection. Right? Like
now that's after we have the ability to allow someone to watch, right? Because otherwise you've just made it extremely expensive to initialize a list watch.
But it's easy to get around that because you just turn on pagination and you're good.
Pagination doesn't work if you have the watch cache name.
You can still make paginated list requests.
They get ignored.
You get entire collection as a response.
Pagination, when you submit a paginated request to the watch cache, it's ignored. I even provided a code ref last time this came up because someone said that's not how that works. And I said, here's the code. I'll find it in the agenda for you. But yeah,
okay.
Pagination with a watch cache doesn't paginate.
That doesn't seem right. Maybe we should fix that. I know it. The way I thought it worked is if you requested pagination, then it won't go to the watch cache. It'll request from etcd.
I will pull up that code ref, and as I recall it, we were not. I mean, we were trying to think of a way to do it while using the watch cache. I guess if we just wanted to ignore the watch cache entirely.
Yeah, just ignore the watch cache and go to etcd.
I believe that had other repercussions.
I think the way there's different ways of requesting from watch cache. I mean, you can specify resource version 0, or you can specify resource version something. And for resource version something other than 0, it just goes to etcd in that case. But for resource version 0, it always lists from watch cache. And then it ignores pagination.
And that happens to be how every informer makes this request.
The first request after initialization, yes. Mm-hmm.
Yeah, or if it gets back a resource version too old, as I recall.
No, then it no longer. Then it sets actually the resource version equal last resource version that I received, and then it gets paginated, I think.
So it was from the December 1st call, and the code refs are linked in the agenda.
Okay, it seems like we need some more time to think about this.
Yeah, I understand. It's not. Yeah, I mean, it's complicated and deep topic. So yeah, take your time.
Yeah, the proposed server change, if I understood it and I need to read it, I'm fine with that, but I don't think it's sufficient. That's where I am right now. Should we wrap it up maybe?
Sounds good. Thank you, David, for pointing to the agenda of December 1st. So, I see all the links there, even the diagram. I just added to the last item in the agenda reminder that Thursday triages now move to 9:30 a.m. PST. I hope that is a little bit closer to the Eastern times. So if you want to join, you're always welcome. And that's all I had. Thank you everybody for joining and participating. It's great to have these meetings back, and we will talk to you in 2 weeks. Please stay safe and have a wonderful Wednesday and rest of your week.
Thanks. Bye.
Bye.